Right then, we'll make a start. Thank you very much for joining us this morning. So just throughout December at Mark 3D, we've sort of been focusing on customer applications and parts that we've sort of found over the year that have been quite interesting. And that's why we're just going to share them with you this morning. It's just going to be a bit of fun, and it's a bit of a competitive event. We're going to have Daniel and Seamus going head to head against each other as to why they think their part that they've chosen is the best one. So just going to introduce who we are. I'm Max. I'll be the host this morning, and then just move on to Seamus as well. So Seamus is one of our sales guys, and then we've also got Daniel as well, who's one of our sales guys as well. I don't know if you guys just want to have a quick introduction of who you are.
Yeah, thanks, Max. As you said, Daniel, I've been with Mark 3D a couple of years now. My background's aerospace. I worked at Rolls-Royce as a machinist for about 9 years. Got into additive and found Markforged, and because of the end-use properties of the material, it was a nice spot for me to sit in, and found some nice, interesting applications. Hopefully, I'm going to beat Seamus today. So I'll let the parts do the talking.
Cool, thanks, Danny. Just before I introduce myself, I've just had someone on the chat say they're not getting sound through their machine. Hopefully everyone else can. Oh, no, there you go.
He's found it.
Perfect. Well, yeah, morning, everyone. My name's Seamus. I've been with the company about 9 months. It's just at the start of lockdown, actually, if we all remember that far back. So it's been quite an interesting year for me. I've moved over from the CAD world into additive, which has been amazing. Still amazed by the technology, and yeah, excited to be here this morning to share some of those applications that I've learned with you all.
Fantastic, thank you guys. Right, we'll just move on. So we've got a new announcement from Markforged last week. So I don't know if there's any Markforged users that have joined us this morning, but they have released a new form of Onyx material. So this material is Onyx ESD. So Onyx ESD is electrostatic dissipative material. This is available on the industrial series machines. So this is the X3, the X5, and the X7 machines. So it meets the ESD protection requirements. It's actually stronger and stiffer than Onyx itself, probably only by a little bit. And this is an ideal material for the electronics and electrical engineering industry. And it also does still keep the outstanding finish like Onyx does itself. So if there's any interest in this material, we'll be more than happy to have a conversation with you guys at the end of this webinar and discuss it further. So moving on, the rules for Battle of the Parts this morning. So what we've got is we're going to talk through 5 parts in each category. We've got a few different categories: best composite part, best end use part, best production aid, best assembly, and then best metal part / application. We're going to keep it to a time limit because I know that some of the guys can do quite a bit of talking. So we're going to do 2 minutes per pitch in each category. And basically they're going to highlight the key benefits and why it should be the winner of that round. And what we've actually got set up on the webinar is that we're going to do a bit of a poll for you guys. So at the end of each round, what you'll see is I'll share a little poll, and then you can then vote for your winner, depending on who you think's got the better application. So let's move on then. So we've got round 1. Best composite. So we did do heads or tails before this, and I believe Seamus won. So we're going to move on to Seamus, and he will give you 2 minutes explaining why his part is the best composite part, and then we'll move on to Danny. What I'll do is I'll get a timer going, and then I'll interrupt you guys when your 2 minutes is up. So, Seamus, when you're ready, I will play the video, and you can your 2 minutes can begin after the video.
Thanks, Max. I haven't got the part for this one in front of me, but we do have the parts for the others, just because it's quite large, and it's also good to show this one in action, which is a bit difficult to do here, as it's a lifting jig for lifting different components of engines. So large engine maintenance, quite difficult to show this off in our office, but we can see the jig there on the right. So the main bulk of it is 3D printed and reinforced with carbon fiber, hence why I put it in the category for best composite. You know, really for me, it's a great it's a great application of showing just the strength and the benefits of reinforcing these sorts of parts. You know, huge strength that we can get replacing other metal or aluminium components. It's actually the world's first CE certified lifting jig, and it was tested to 960 kilograms of lifting, and printing it in composite materials has allowed them to make a much lighter and a much more compact lifting jig, which is great for transport, for maintenance, both in-house and and taking on site wherever anywhere over the world. With the jig and the engines. So yeah, just a great example of why the strength that can be achieved with reinforcing composites is so beneficial.
Okay, lovely. Thank you very much, Seamus. About 30 seconds left on that, but that's not a problem. I
right.
Highlighted all the key points.
I was obviously rushing because I was on the time limit.
Yeah, no, I know. I'm not sure if a bit of for the people watching the webinar, I'm not sure if there was a bit of interruption with the video. Whilst it was trying to speak over to you, but hopefully they heard what you had to say, and it was clear. So that's great. So what we'll now do is move on to Daniel for his round one. What I'm just going to do at the minute, I've just had someone pop that on chat. Okay.
Yeah, they're just saying the sound was good.
Yeah, lovely. That's good to hear then. Good. So yeah, we'll move on to Daniel. I'm just going to stop the PowerPoint for a moment because Daniel's actually got the parts with him. So we're just going to make him jump onto the big screen so you can see it a bit more clearly. So I'll stop this, and then Daniel, I'll pass it over to you to do your round one for best composite part.
Yes. You tell me when the timer goes.
Yeah, hold on, that's what I've forgotten. Right then, start. You're good to go.
Perfect. So the thing with the Markforged composites, one of the key fundamentals is strength. So as Seamus demonstrated with the lifting jig, I've got a part here which is a bit difficult to describe, in all honesty. Essentially, it's like a collarbone of a robot. So this is a company called Robo Challenge. And basically, this guy, it's like an engineer's dream. When I had a wander around there, he'd got an ABB arm with a milling cutter on, cutting like a Terminator out of foam. They do things for theme parks, video games, but his passion is these robotics. And basically, if you've ever seen Robot Wars, he built all of those. But there's like a version of Robot Wars on steroids for engineers gone crazy with endless budget by the looks of it. And his key constraints were making it lighter. Now, the main reason for this is he's got to power his unit for 3 minutes. The lighter it is, the less battery pack he needs, the lighter it is in terms of battery, because that's the heaviest part. So he was making these out of aluminium, milled aluminium. They were costing about £400 with a lead time of 2 weeks. He's got a Mark II, a desktop printer, reinforced it with carbon fiber. Obviously, I'm not going to be able to break that, but it's about £25 overnight now for a pair. And it's about 50% of the weight of an aluminium part. He's taking it on from there. I'm cheating a little bit here. I'm going to throw in another little part, but we've got a mount, like a cover for a bespoke DC motor that they developed. This thing, if you ever come to one of our events, Factory of the Future, sometimes we call it, it is amazing. Got like a crushing power. It looks a bit like a saber-toothed tiger, this robot. 22 tons of pressure at the tip of the tooth. It is phenomenal. And he is basically the world champion with it. And he wouldn't be without our parts. I'll leave that. I don't know how long 2 minutes is, to be honest.
No, that is bang on time. That was you 2 seconds left, so that was spot on. Thanks for that, Daniel. That was very informative. So what we're now going to do is I'm just going to take it to a poll. So for you guys that have been listening, give your chance to say what you think was the better application. You've heard from both our guys. So I'm just going to pop this up on the screen there. So that's on there. And then if you want to get your votes in, and we can see who we have for the first round.
May not be able to see it. Oh.
Yeah, so you should be able to see it on your screen now, guys.
I think I'm going to submit a formal complaint to the ref for that. It's 2 parts. To be
honest there, mate, I had to make up for the fact you didn't have one.
Okay, yeah, fair point.
I'm seeing the scores come in live now. Ooh. So there's a few more votes to come in. It's down to the last vote. So I'll give it a couple more seconds, and then we'll have to see. We could really do with that last person voting. It would be very helpful, but it's not a problem. Okay, so for that round, I'm going to have to leave it there. So I'm just going to end that. So for the results of that round, we had a 50-50 draw. So the people on the webinar were impressed with both applications. So unfortunately, I can't announce a winner for that round just yet. So we'll have to see how the rest of the categories go.
No, you might have to make a tie break at the end.
Yeah, no, this is what
make up a rule.
Yeah, we'll have to we'll sort something out. So moving on to round 2 that we've got. So this round is for best end use part. So as Seamus went first last round, Danny, do you want to kick us off for best end use part, what you've got?
Yeah, would you tell me when you're ready?
Yeah.
Okay. So this is from a customer of mine called Clenaware. Cracking guy, lovely little business, making things essentially like, well, they're dishwashers, but industrial dishwashers for pubs, clubs, hospitals where there's a high throughput. You may have heard me talk about it on the last webinar we did. But I visited him the other week, and he started off with 2 printers, and it was a supply chain issue. Now, that's never been more apparent than it has been over the past year. Essentially, someone scrapped his mold tool for a filter, bought a couple of printers and printed them. He can develop faster, all these kind of things. When I visited him the other day, someone else had let him down. Basically this, if you can see it, doesn't look obviously overly interesting on the surface, but what it is it's the control panel off the front of one of his dishwashers. So this is where all the buttons and the LEDs and bits and pieces go into. Now, if he can't get his part, if he's 1 part short, he can't sell his machines. So what he actually did is he printed one, but realized he could take it a stage further. He didn't have the constraints of injection molding. So this was normally made up of 6 parts, an element of clips and other kind of seals and bits and pieces, re-engineered it so it prints as 1 part. That costs, it's under £2 in material when it's just Onyx. If we reinforce it with a bit of fibre, a couple of quid, he can have a bed full of these on his industrial printer, printing overnight, and away he goes. What it really proves, though, is although this is kind of an everyday part, it's an end-use part. This has got to last in a hospital or a pub for years and years on end without failing. And it just goes to show how it's basically gone past injection molding. Now, I'm not talking necessarily all the different materials or qualities, but longevity of the part and the ability to redesign so you make your part smarter, cheaper, And the best thing for him really is he doesn't have a minimum order quantity. He was having to order 500 of these at a time. You know, that's a lot of dishwashers you have to make, when now he can literally print on demand, on time. So it's a phenomenal application. And to be honest, he's got his latest product, one of his dryers for glasses, is 70% printed. It is amazing how far he's took this technology.
Right then, Danny, I'm going to have to stop you there. Thank you very much. That was just over the 2-minute mark, but thank you for that.
Thanks.
So I hope everyone got the application for that. Seamus, do you want to take yours away?
Yep, perfect. Cool. Thanks, Max. So I have a bit of a different part. It's actually a hinge, and the reason I've included this one is it really shows what is achievable with the printers and just sort of how agile they can be. Now, you know, typically Markforged printers are known, or composite printers are known for their strength, but actually in this one we're utilising the flexibility of the Onyx material. You know, when it's printed quite thinly. Okay, so if we take a look here, we can, don't know why it's doing that. Yeah, moving the camera. If we take a look, the main sort of bits are printed quite thick layers, and right in the middle we have about eight layers of the plastic, so a really thin part which makes it very moldable. Okay. So printing this, we can have what we're calling it a living hinge. You know, so it can easily move and flex with the material, and again it just shows, you know, what is possible. You know, if you just sort of push the boundaries of the technology a little bit. Now, we did actually have this tested for fatigue, and it lasted totally 5 bends a day, every day for 102 years, which in total is 186,000 bends before breaking. Yeah, so a huge amount of life. And the nice thing is with additive, if it did break, it's very cheap to print another one. Or something that a colleague actually showed me this morning is, you know, why not have them interchangeable? So instead of bolting them in, print sort of a circular bit to the end or whatever it might be, and actually slot that in. So just slot it in, pull it out, nice and easy to change that. And the last bit, we've printed it this way so that when you bend it, it flips back to being normally open, if you like. If you actually printed it in a different direction and printed it 90 degrees, so just altering your CAD and printing it that way, you can now have a normally closed hinge. So it would sit like that naturally. You just put it open and it would flip back and now become a normally closed hinge. A great and different use of the technology there as well.
Lovely. Thank you very much for that, Seamus. That was your 2 minutes just up. So that's perfect. Thank you very much. So what we'll do is we'll now take it to the polls and see which part you thought was the best or the best end use part. So let me. So I'm just going to launch the polling now for best end use part. Okay, so we've got the votes coming in. Quite one-sided at the minute. I'm not gonna lie. If I was voting, I'd probably vote for this part as well. All right then. I think I'll just give it another couple more seconds just to see. We've got a few comments coming in on the chat.
So it's always the ref that gets the bad stick, isn't it?
I know. The ref is always the bad guy. It's always the case. So I'm going to end the polling there. So we have Seamus, who has taken that round quite easily, Danny. quite easily. So well done to you, Seamus, for that round. Yeah, for me, if I was voting, I think the living hinge for me would be the application that I'd choose also, just because of the sort of, if you've worked with the Onyx material and how sort of versatile it is, from sort of how strong it can be to then sort of, you know, how flexible that we've made that living hinge. And I think that's the winner for me also. But I'm not being biased. That's
Well done, Seamus.
That's good sportsmanship. Thank you, Danny. Right then, so we'll move on to round 3, which we've got best production aid. So, Danny, do you want to lead us from for best production aid?
Yeah, perfect. So the next one.
Give me a moment. Let me get the timer up. Sorry, I know you're eager. So you can begin.
Okay, so the next one is a production aid from Leonardo Helicopters. Basically, I'll give you a second to have a little look at it. What I want you to take note of is this thing, although it looks fairly simple in terms of geometry, it is horrible. Being aerospace, it is curved in every axis. And what this is a drilling jig for the top of a Lynx helicopter. So they're composite panels. And what they're going to do is basically that hole in the center there, drill, bung that, and then route out a panel to get to an electronics mod. And then these 8 holes around the outside are all for drills to then put a patch over the top of that mod. So it's an aftermarket mod, essentially. But the reason this is such a good production aid is this used to be bull-nose milled out of solid aluminium. It cost thousands. Took an absolute age from the tool room. And then there's other issues in terms of it's all about accuracy. Now, that's one thing the Markforged printers over and above strength is known for, is repeatability and accuracy. Basically, I mean, imagine you holding this over your head, trying to drill. If you drop that one, it's going to plonk you on the head. 2, might scratch what is essentially a multi-million-pound aircraft. This is what we did as a trial, and to get the technology proven out in-house. It's been developed somewhat since then. A lot of the material has been taken away, integrated handles, and it just will go on and on. Obviously, we put bushes where there's going to be a drill bit. Obviously, at any wear points, we want to use parts that are durable enough to withstand that. But what's really impressive on this is it was put on a CMM machine. And obviously the measurements taken, and basically most of them are nominal, about 50 microns tolerance, which was more than accurate enough for what they needed it for. And it was in some axes more accurate than machining with a 5-axis milling machine. So phenomenal result. That's just one part of what is now a whole host of production aids on the production line down in Yeovil.
Right, Danny, thank you very much. That was your 2 minutes up. Thanks for that. That was very informative and a great application for best production aid. Seamus, do you want to take it away for your pick for round 3?
Yeah, cool. Thanks, Max. So I have what really is more of a production prototype, but I think it's fair to say that it is a production aid. It's helped them make the right choices for production. It's from a company called Gazco that make fires, wood burners, things like that. They're actually quite new to printers, so it's amazing to see how fast they're coming along. I think this was about day 4 of the printer being on house. They sent me a video of using this, which was incredible. So it's a sheet metal bending die. It's fairly small, and it's really they just needed to test that the die design that they were going to invest in was correct, and the bend radius that they needed was quite difficult to calculate. So with the printer there, it just made sense. Print it, test it, go. It's actually been printed in 2 parts. If you can see it, there's like this sort of rim around the outside, and that's actually to improve the strength. 3D printing, we're building up in layers, which means they are anisotropic materials. So getting the strength in that 3rd direction is a great way to do that. Just print in 2 parts, print in 2 different orientations, and you're able to get that strength. A great bit of design, a design for additive there as well. Actually testing this, they found they did need a larger size. So, a great production aid there to make the right decision. They very quickly saw it was wrong. They would have invested in, expensive tooling. It would have been quite a lot, quite a bit of time until they would have had that part in, tested it and found it. This was printed pretty much overnight in a few hours, straight on the machine the next day. did, you know, they could change the design test again and make sure that when they did invest in, you know, in the tooling that they needed long term, you know, they were making the right decision. So yeah, great little production aid, solved a great problem, and a great use of additive.
Lovely, spot on, bang on the 2 minutes. Thank you for that, Seamus. That was great. Yeah, so we've got 2 different production sort of aids there. So what we'll do is we'll take it to the poll, and we'll see what you guys think was the better application. So I'll launch the poll in now. Let's see the votes come in. So 2 quite different sort of applications there. Okay, this is interesting. So I'll just give it a couple more seconds to get the last final few votes in. All right, then I think we'll stop it there. Thank you very much for that. So well done to Danny. So the production aid for the jig. So yeah, just to add to that, that part is, I know it doesn't look quite as complex on the sort of camera, but I remember sort of sitting down and trying to print it. It must have been sort of 4 or 5 different orientations before we managed to get the print spot on. So yeah, it's yeah, a good application. Thanks very much. So just moving on to round 4, I'm just going to pop up the PowerPoint again, just because I know that a few of the guys have got another video to share. So give me a moment. Just skip through these. So round 4, we've got assembly, and I'll just start off with this one. So I believe it's Seamus to go first. I'll just get the 2 minutes on the timer, and then you can go now, Seamus. Thank you.
Cool, thanks, Max. If you can just start that video, it is a video.
Okay.
Yeah, thanks. And I could definitely talk about this one for longer than 2 minutes, but it just shows so many great examples of what you can do with additive. So I'll try and highlight a few. So this is a laser marking jig from a company called Corin Medical. Now, the jig holds different parts which go into the laser marker for laser marking. Being a medical company, the laser marking needs to be very precise. So accuracy and rigidity was a huge thing here. You can just see one of the guys at Corin just snapping some bits onto the end there. So this is actually the hold. So the white part is essentially the holder for various different parts that they have. And then the Onyx, the black part, is the actual jig, which you could see him snapping into different orientations. Okay? So a great example of additive there, because it's all about swapping out standard components. Yeah, the Onyx parts, the black parts are always the same every time. So you print them once and you reuse them, you know, and you snap different things onto the end, which are the white parts, and they're the actual holders. Okay, so that's the first great example. Moving it into different orientations as well. You know, the way that it's done is with ball bearings on springs, I believe. So, you know, this is a great example of adding other hardware into your prints as well, you know, to mix the benefits and additive with, you know, a lot of other hardware that's available, you know, standard things like springs. And previously they were putting just the negatives of their parts on. So they went from about 80 different jigs down to this one which holds 4. So a lot more versatile. It can hold more parts in the laser marker as well. You know, from a design, from additive point of view, you know, just so many good examples of designing for the process. You know, things like complexity. We would say complexity is free with additive. You know, you can make very complex geometry very quickly and cheaply. You know, and you can really see that here. You know, whether this would have been possible with other manufacturing applications. You know, I'm not going to say yes or no, but you know, it certainly wouldn't have been as you know, as cheap or as quick as printing. So yeah, there's so much more to say, but you know, with the 2 minutes, that's just a couple of highlights.
Thank you very much, Seamus. That is your 2 minutes and a little bit more.
I probably went a bit over. Yeah.
I know that you can talk about that one quite a lot. It's a great application. So Danny, I'll pass it over to you now. I'll just stop sharing the presentation. Have you got the part?
No, there's a slide there, mate. If you can just show a slide. Sorry. I've got a part, so you'll have to kill the presentation in a minute, but it's part of a part because the assembly is so big.
No problem. I will pass that. Okay then, so
if you just press across again, might as well put all the pictures up in one go.
Yeah, there we go.
That'll do us. Right. So you tell me when the 2 minutes starts and I'll...
Yeah, just
okay.
You're good to go.
Perfect. So this is a great company, Dunlop, and by this we're talking about Dunlop systems or components. And what these guys do is make hydrogas suspension units, particularly aftermarket ones for people like Land Rover and things like that. Now they're masters of their craft. They know what they're doing. Their difficulty came in particular with when they want to win a new contract. They have to produce prototypes, and the tooling cost around that is astronomical. So what you can see here on the left, basically, there's a lot of forming of rubber, vulcanized rubber. On the left, that's a traditional machine, which they put this rubber over a mandrel and heat it up before it goes to be formed. Now, those machines cost nearly £12,000 each, and they needed about 8 just to win a contract. So you're talking phenomenal figures there. What Mark Statham did, he's a bit of a mad scientist with this technology. He took it, he had one Mark II, a desktop printer, needed a part that's over 1 metre tall, the part that you can see in the middle there, printed it in sections with gaskets in, bolted it all together. If you drop out the presentation, mate, I'll be able to show the part now. So obviously I can't show you the entire part because it's so big, but you can see the end part of it there. So it's got gas fittings in the end. I don't know if the camera picks out with O-rings. So it holds a couple of bar of pressure. It's heated to about 110 degrees and it's all printed. So printed pegs and assemblies come apart and all gas channels with kooky geometry running through them go through there. He managed to produce a prototype for £1,000, negating all them tens of thousands of pounds worth of tooling that was just needed to get a prototype. So you've got a phenomenal production aid there that's operating at high temperature, gas tight. You know, that one that I just showed you a minute ago is actually off a helium testing rig. And he's gone so far beyond there with all kinds of production aids. I'm going to chuck another part in because I'm running over on time, but magnets, collars with drill bits, drill guides in there. He does all kinds of things. But it's a phenomenal assembly, over 1 metre tall, of a tiny little desktop machine. It's cracking when you see it.
Thank you very much, Danny. That was your 2 minutes and a little bit as well. I thought I'd let you carry on because I know you do like that part. So thanks for that, guys. 2 great parts there and some assemblies just to show you the sort of scale of the parts that you can print from sort of desktop and industrial printers from Markforged. What we'll do is we'll take it to the polls. So I feel like this might be a close round because there's 2 very good applications there. So I'll take it to the poll. We've got best assembly and we'll get that going now. So let's get your votes in and see who you thought had the better assembly.
I think it's fair to say this was the most hotly contested one in the office the last 2 weeks, isn't it? We've both been keeping these ones up our sleeve.
Yeah, keeping them quiet. So
great stuff.
No.
Mute, Danny.
You advertise this to all your customers, saying, "Come in and vote for your own part."
Okay then. So I'll give it a few more minutes, well not minutes, a few more seconds just to get the last few votes in. And okay, thank you very much. So we have a winner of Danny again. So well done, Danny. Seamus. Oh dear, what's going on, mate? Come on. No worries. Well, hopefully you can shine on this final round. So the final round is the best metal application. So I know that you guys will just need the screen up. So if Seamus, you want to kick us off with best metal application?
Yeah, I can do. I'm going to have to win this one, otherwise.
Yeah, I know. So the 2 minutes is on the clock now.
Cool. So I have a part here from Stanley Black & Decker. So, you know, a company that everyone knows, but you may not know the bit that goes on. It actually goes on a hydraulic, hydraulic pod, essentially, hydraulic thumper. Yeah. It goes sort of right at the end. It does actually have hydraulic fluid going through it, so it's a connector between the hydraulic and the ram. It was actually initially made, a bit of the story behind it was made in 3 different parts originally, so that was before it was printed, and this was causing some service problems in the field. You know, obviously making 3 parts as well has its downsides, you know, the assembly that goes with that, all of that sort of thing. So, you know, looking at metal, you know, a great thing about 3D printing, you know, complexity is free. You know, you're able to make geometry that can't be done with other manufacturing methods. So the design, with some tweaks, was made so that it can be printed all in one part. You know, some of the ones to highlight there, if you look at the hole, you can see that it's sort of triangular shaped to the top. This is a classic thing that we do with printing, because it means that holes don't need to be supported. You might have seen it on the assembly that I showed before as well, if you spotted it in the video. But yeah, just you know, some slight design changes, and this part is now printed in metal in one, so it just comes straight off the printer, straight into the tinter, and then, you know, straight onto the part with no post processing, no assembly needed. So yeah, a great example of a metal part that's you know, replaced the previous part and giving you those added benefits of going from 3 parts to 1. You know, easy servicing, easy swapping for replacements. Good stuff.
Lovely.
Hang on 2 minutes.
Seamus. That was very informative and a great metal application. Danny, what have you got up your sleeve?
Okay, we ready? So this...
Sorry, I'll get it on the timer.
No worries.
Right, you're good to go.
This is the jewel in my crown. Basically, something close to my heart, being an ex-machinist. Milling cutters made in H13 tool steel. Now you think, well, what's special about a milling cutter? Well, what's really phenomenal about these milling cutters is they're bespoke. They're not your 10 mil, end mills, all these kind of things, slot mills, drills. They're bespoke to cut specific geometry, mainly for automotive and aerospace. You can see obviously the profile of the cutting edge there. You can do whatever you want with these in terms of, you could have 3 diameters of particular sizes in one plunge. But what's really key is the fact that we can put coolant wherever we want. We've got through tool coolant with an aperture running through the center of the tool that can mirror the profile of the cutting edge. Now, what that means for the non-machinists among you is more efficient swarf removal, better heat management, faster cutting speeds, and longer tool life, all of which means more parts made at a cheaper cost. Not only that, we can lightweight these. So if you've got the tooling, for example, on the end of robotic arms, or you're using things like fast movements, the inertia is a lot less, because it's essentially at least a 50% weight saving, because it's triangles inside there. We can finish the skin size to whatever we want. But this is just one of a couple of tools. We've got a keyway cutter here. The most impressive, which I don't have with me today, is what we call an ejector drill, which delivers the coolant through the walls of the tool ahead of the cutting tip and blows it back through a channel through the center of the tool, ejecting the swarf, meaning nothing's left in the hole. So if you're drilling a hole through to a chamber that it could get stuck in, it ejects it back out. And there's just no way of manufacturing that apart from additive. But what that meant for this company, Corin, is a 25% cost saving, because essentially we're producing a tool without any swarf being made. It's kind of weird considering we're making milling cutters with additive, but it's the lead time cut massively. They don't have to get bespoke tungsten carbide manufactured. We're saving 75% on the manufacturing times, which means customers are getting their parts quicker. How are we doing for time? Because I could carry on.
You've just gone over your time. I know that you could have spoke about that a little bit longer, because I know
I love that one. That one's my favourite.
It is a great application. I know. So what we'll do is we'll let the people on the webinar decide what they think is the best application. So you've seen the two metal applications there that we've got, two slightly different but very good use of the metal technology used by Markforged. So I'll take it to the polls. And we'll just wait for the votes to come in. So that's now live, guys. So if you want to input your votes, that would be great. And let's see the final result that we've got here. Okay. Okay, I'll give it a couple more seconds just for any more votes to come through at the end there. Okay, I'll stop the voting there. Thank you very much, guys. So what I'll do, I'll just make a note of that one, and I'll just pop onto the presentation screen, because if anyone, right then, so just been through round 5. So we're just going through the overview and a winner of the parts battle this morning. So I make it, well, the first round we had was a draw. The second round went to Seamus. And then the last 3 rounds we had Danny, who took the victory. I know that someone did pop up on the chat on round 1 saying that there was 2 of them in the webinar. So I don't know if that second person they are with wanted to cast their vote for the winner. I know it's back to round 1, or if they can remember. If just so, Seamus, your defeat doesn't look as bad. So at the minute,
or it gets worse.
I've got a chat come through, so let's just let's see what they've said. So okay, so actually they've evened, well, I say evened it up, but they actually gave the round to Seamus. So 3-2 to Danny overall, which is great, guys. So congratulations, Danny.
Cheers, well played, Seamus.
Yeah, there's some good parts on there, guys, and I think you've showed off some real good applications of what you can do with the Markforged printing technology, metal and composite, and just Onyx components as well. So we'll just highlight over, and then if anyone's got any questions about the applications that we've gone through this morning, we're open to some questions. If anyone's got any questions, that would be fantastic. You can just pop them through on the chat, and we will try and answer them for you guys regarding each application.
Or just any general questions at all.
Yeah, or just any general questions about the technology. So I've got a question come through. Okay, so I've got Seamus, this one's for you. So can you tell us more about the living hinge? The fatigue life you mentioned was really interesting. So I don't know if you just want to sort of read through those notes again that you've got and just explain a little bit more about the living hinge. That'd be great.
Yeah, sure. So I guess a little bit more about how it was printed. It was sort of working with a customer of ours, just about could they do this sort of thing, and it was a bit of a test for us. We had to try a few different things to get it to work. In the end, it was 8 layers along the sort of thinnest bit, which with the standard settings, if you're familiar with the printer technology, means essentially four roof layers and 4 wall layers. So there's 8 completely solid layers of Onyx right in the middle there, which gives you the sort of perfect balance between the fatigue life that you need and the flexibility for it to obviously be a hinge and move, and as it thermoplastic, it will stretch and then move back. So the middle section there's about 0.8 millimeters thick, and then again you could add anything onto the end really, or have the middle part thinner, so thinner, thicker, easily change what's on the outside. Again, here we've got it bolted in as it was for a company that makes cases, but again, I saw something this morning where in the parts that were hinging, you had again diamond holes, which you then had the actual solid diamond geometry on the end of here, and that would just slot in and out, so just a bit in and out, so easily change it if it warped, change it to different things. And then the test, as I said, we had a machine made to test it, and it was about 100. Well, just over 180,000 bends before breaking, which is a great one.
Lovely.
If you want more detail on it, we have some reports from the customer. We've got some information on exactly how we printed it, and we can probably share this file as well. It's quite generic with you also. So yeah.
Fantastic. Thank you very much. Yeah. So, like Seamus said, that hinge, really quite interesting, with how you can sort of, that's probably sort of like the first iteration of it. I think it can be a bit more advanced, can't we, to make it sort of interchangeable, so it sort of has that product life cycle lasting longer. So if there's any more questions, if you'd like to just pop them in the chat, just give it a minute or so, and just with that, we'll just sort of discuss how we thought the rounds went today. So, Danny, I know that you had the part from Clenaware, and unfortunately you lost that round. How do you think that? What do you think the factor was to losing that round?
I've got to be honest, I'm more concerned with explaining myself to the customer. It's a cracking part. He's got 11 machines. I don't know what I'm going to say to him.
I know.
But to be fair, Seamus's part was good. The living hinge. Like we were saying, it was more a case which maybe I didn't put across properly, how a small business has made themselves so much more resilient through this process, rather than relying on supply chains, taking control over their costs and taking control over development, essentially making new products. He's a maker now. Before, he was, with the greatest respect, just bought parts in and assembled on site. Now he's got 11 printers printing virtually 24/7, and the more he can print, the cheaper his machines are. But he's making big gains with redesigns and benefiting the materials. So it is a cracking application, just not good enough to win.
No, that's I know. No, it was a great part, and that's just, like you say, one of many parts that customer has done on his range of printers that he's got. So what we'll do, it doesn't seem like there's any more questions come in, so we'll just wrap it up towards the end. So what we'll do, just moving on. So like I said, if anyone wants any more information regarding the Markforged technology, or has got any questions, then you can reach out to us on the email below, printstronger@mark3d.co.uk, or just get in contact with us via the phone. So it's just been good to sort of run through the applications this morning, and I hope you've learned a bit, and sort of with people that use the printers out there that have joined us this morning, giving you a bit more inspiration, looking at different customer applications also.
If I just add in there, Max, if anyone wants a sample of the material, is interested in using the software, or just ask questions, please reach out. There's a lot of things we didn't touch on today, such as flame retardant materials. We talked about the new ESD. There's a lot that hasn't been covered in these. We were just hoping, trying to stimulate your imagination, giving you a flavour for what is achievable. But reach out with your applications, even if you just want a 10-minute call to chat through whether something's possible. Let us know.
Lovely. Thank you. And and from us at Mark3D, we'd just like to say Merry Christmas and a Happy New Year. And if we don't hear from you in the end of this year, and then hopefully we'll hear off you next year. So thanks very much for joining us this morning. We hope it's been informative and sort of opened your mind a bit more about the Markforged technology. So yeah, thank you very much for joining us this morning.
Thanks, everyone.
Cheers.
Thanks, everyone.